Hello, welcome to our webinar on how to teach science using environmental phenomena. If you're not very familiar with California's environmental principles and concepts, we're hoping that you've had a chance to download it. We showed the link there. We also have a handout box in the GoToWebinar box at the far right side of your screen. So there is an EP&C flyer on that. So go ahead and get that for your reference. We'll be using it a bit. I'm Christy Porter, and I'm a senior environmental scientist here at CalRecycle's Office of Education and the Environment. And we're the ones who've brought you the Education and the Environment Initiative curriculum. I'm guessing that, Barbara, quite a few people in our audience have used that. Our mission here is to increase environmental literacy in kindergarten through 12th grade students. And this webinar, we're moving beyond the EEI curriculum. So Barbara Woods has been with our EEI program for many years. She was one of our field testing teachers. She was an EEI teacher ambassador for years, doing in-person professional development and trainings. And Barbara, I'm going to let you tell the audience about what you're doing now.
So just to give you a little background, I taught in several grade levels in the Gulf Joint Union Elementary School District. I served as a district curriculum coach for several years and for 4 years as the NGSS Early Implementer Project Director. I'm currently on loan to CalRecycle, working with NGSS and environmental education. And I also serve on Achieve Science Peer Review panel, reviewing NGSS curriculum from across the nation.
And we're thrilled to have Barbara on contract with us. Since at CalRecycle, I'm an environmental scientist, so it really helps to have that teacher expertise. So let's see what we're going to look at today. We are going to be exploring California's environmental principles and concepts, seeing how it can be applied to especially science instruction. We're going to be sharing some examples of environmental phenomena that can be used as a focal point for kindergarten through 5th grade lessons. So I want to clarify right here at the beginning, we're not going to be showing lesson sequences and exactly how to teach about those phenomena, but we are going to be highlighting phenomena and showing NGSS and EP&C connections. And then finally, we're also going to be looking at some of the EEI curriculum resources that might be used to support some of those phenomena.
Yeah, so our goal is to inspire you, to whet your appetite, to get your thinking going on new ways to be able to, or new ways or possibly just tweaks to old ways to put environmental literacy into what you're teaching happens throughout the day.
And I wanted to note for our audience, you're going to see this closed captioning at the bottom of your screen. You can't turn that off, but we're doing this to meet accessibility requirements and so that it's easier for more folks to access our materials. So Barbara, I know you have been teaching using the environment as a context for many years, even before EEI came along. So tell us why you like using the environment as a context for learning.
Well, first of all, I'd like to say if this was a live workshop, we'd be asking all of you to share your ideas about why you think teaching the environment as a context is valuable. But since you are not here, hopefully some of these ideas that come forth that you see on the slide will match what your answers are. The idea that it's relevant when we encounter real earth problems or issues, the students see that learning is becoming relevant. And when it's empowering, the idea of being empowering, students see this context and figure out a way that they can make a difference. And that also supports an equitable classroom atmosphere. Of course, it becomes very motivating because they see how their own efforts, the efforts of others, can work towards meaningful change. And we develop different perspectives from different points of view and connect it across the disciplines throughout the day and throughout the year so that students can see how this environmental thread can be used in all that they learn.
So Barbara, we want to get an idea of who's out there in our audience. We actually advertise this as a kindergarten through 5th grade webinar. So I am going to launch a poll So if you can all click and tell us who you are, K2, 3, 5, we might even have some middle school or high school, admin, or maybe even some others. I am going to go ahead and close that and share the results. Let's see who we've got. Well, we've got mostly 3 through 5.
Yeah. And we have some administrators or coaches or TOSAs, other people in that type of position, and some non-formal educators also.
Okay, well, great. Well, that helps us.
We do have some K through second, though, a few.
Okay, so let's keep moving on. So, Barbara, when NGSS came around at first and there was all this talk about using phenomena, I didn't know what they were talking about. So I'm guessing most people have a better idea now, but why don't you give us a little brief overview?
So there are many variations of the understanding. So it's not just you, it's everybody. We see lots of different things happening. So we can look at these points that are on the slide here. It's an observable event or process that causes one to wonder. It can be natural or human built, so it could be a dam. It's explainable, but too complex to explain after a single lesson or even just a few lessons. You want students to need to work at explaining it. And it turns the focus of learning shifts from the learning about the topic to figuring out why or how something happens. So we use the phenomena to drive the instruction.
Okay, and that really takes us into NGSS and how it supports it.
Yeah, so as we look at NGSS, hopefully most of you have some familiarity with this, but we can do a brief review. We have the 3 dimensions of NGSS, which include the science and engineering practices. Those are the how we do things. The disciplinary core ideas are what we learn about, and the cross-cutting concepts is kind of the thinking that goes across the different disciplines. In addition to that, we use phenomena as a way to make sense of what students are learning. And so the goal is to build knowledge by using the engineering practices, science and engineering practices, in conjunction with the cross-cutting concepts. And that develops their core ideas, and we use it based on evidence because it's science, and they can explain and predict phenomena.
Okay, so that was our quickie crash course in NGSS, right?
And if you need to know more, we have in the handouts an NGSS cheat sheet that will give you a little more information. There's plenty of places to go for learning more.
Yes, so we want to do another quick poll, getting an idea where you are on your NGSS journey. So we are going to launch that. If you could give us a quick response. Okay,
So
I'm going to close it in a moment here. Okay.
So as you can see, we have a pretty good range of people that are just at the beginning of learning about NGSS and those who are often teaching NGSS in their setting. So a lot of people aren't claiming that they always implement 3D NGSS, and I think that that's very realistic. It would be hard to answer always.
And Barbara, for those who are somewhat new as well, we are going to be talking about some of the NGSS rollouts, the next series, and how you can sign up for those. So we'll talk about that in a little bit, and that'll be valuable for everyone. Okay, so now let's really dig into the content of why we're here. Barbara, let's take a look at our first phenomena.
So typically we would have students pose with the idea of what do you notice? What do you wonder? And we would ask students to just share with us that. So Christy, talk about what do you notice? What do you wonder in these photos?
I think my main wondering is what that hillside might have looked like before they started spraying it with water and what it might look like today.
Yeah, so could we go there today to see what it looks like? And I kind of wonder what happened to the debris that was washed away. Where did it go? What did it do? So as you can see, just noticing and wondering often can bring environmental connections here. And you might ask, Barbara, Christy, this looks like a historical type event, not a scientific event. And one of our purposes for selecting this particular phenomenon that shows over time, an event that occurred, was to let you know that we can connect to history, we connect to many other subjects, and pull it out as a science phenomena that we can notice and wonder about and connect it to the environment.
So California has provided that environmental lens as well to be looking at some of what's happening and our instruction and how we can relate it to how humans and natural systems interact. And that environmental lens is in the form of California's environmental principles and concepts. And our office here at CalRecycle actually developed the California Environmental Principles and Concepts back around 2003. So before we wrote the EEI curriculum, we had to figure out, well, what do we think students should know about their relationship with the environment? So we came up with these 5 different big ideas. So let's take a look at them.
Yeah, so with these 5 different ideas, we're just going to briefly look at this slide before we go into a little bit of a detail. We know that many of you are familiar with these. So as we speak of these principles in the next few slides, those of you who are already aware of them, use this as an opportunity to think deeply, make connections beyond what you have before. And if you're familiar with NGSS, think about the cross-cutting concepts and where those connections can be made in these principles that we're showing.
And Barbara, I know we had a few people who have joined us since we first started. So I would tell you that we've got a handout on the EP&Cs and the box on the far right-hand side of your screen. And you can open that up if you want to use that for reference. So this will be our last poll for a while. So we want to find out how familiar you are with California's environmental principles and concepts. I'm going to share it. Yeah, actually 46% just learning about EP&C. So great. We'll be taking a deep dive into those, and for those of you who are familiar,
you'll notice that we'll be providing some examples that will help extend your knowledge. And for those of you that aren't familiar, this will be a quick journey, and we'll have other opportunities where you can do an even more basic approach. But I think you'll get the gist pretty quickly.
Okay, so let's explore Principle 1.
So Principle 1, people depend on natural systems. In other words, in order to enjoy the quality, quantity, and reliability of the goods we use every day, people depend on healthy natural systems. So Christy, when we think about this EP&C, its purpose is to increase student awareness of our dependence on healthy natural systems to provide for our needs. And we can really convey this through thinking involved with the systems and system models cross-cutting concept. So all of these principles refer to systems. So we thought that perhaps a review of the idea that's meant by the term systems would be in order at this point.
I've gone to a couple of trainings, and when we introduced the EP&Cs, some of the teachers are saying, natural systems, I understand natural resources, but what do you mean by natural systems? So just bear with us for a few minutes while we all make sure we understand what a system is. We're going to use a bicycle as a system that we're all familiar with. It has components, a seat, a chain, and tires. There are interactions between all those parts that makes it go. We can look at boundaries of just the chain and what it's connected with. We need an input, a rider, to make it go. There could be limitations. I may not want to ride my bicycle from Sacramento to Los Angeles. And design choices. If I'm going to go for a ride on a rocky trail out in nature, I'm probably not going to want to take a racing bike.
Yeah, so lots of things come in place when we look at a system. So now let's take it to a natural system. we can look at this nest, this photo that was taken by a drone of a great egrets nesting site. This is just south of Sacramento, and it's a rookery where 6 different species actually build their nests and raise their young. So we can look at it just as a system that involves this one nest and the birds that reside in that one nest, and then we can expand it to include the surroundings that provide for their needs, for the food, everything. We can also look at it as a bigger picture and include all 6 species, where they are nesting as far as the height in the trees, and we can go beyond that to include the full ecosystem that's part of this.
So at least everyone has an idea of how or what we mean when we're talking about a natural system now. And this really reminded me of this quote that I think most people are familiar with by John Muir, and it just, to me, it embodies what the EP&Cs are all about, how humans influence natural systems and we depend on natural systems. So let's take a closer look at the other principles.
So now, instead of talking about the fact that we depend on natural systems, we're going on to people influence natural systems. And this kind of involves the fact that there are changes that cause impacts that can be due to the growth of human populations, their consumption rates, and that this involves the extracting, harvesting, transporting, and consuming natural resources to meet our needs. We can connect this to the cross-cutting concept of cause and effect also. Going on to principle 3, look at this. The focus of this principle is about cycles, so natural cycles that occur that people depend on, they can benefit from, and they can influence. Some examples could be the life cycles of bees and salmon have been influenced by human practices, and other examples can be the water cycle, carbon cycle, decomposition, erosion, the interactions of the biosphere, hydrosphere, and more spheres that go on that. And these take on new meaning when they're imbued through this principle, as well as the cross-cutting concept of energy and matter can be connected to it also. Okay. So going on to principle 4, this one, the idea there are no impermeable boundaries when we think of matter and where it goes when we don't necessarily intend for it to go there. This really connects with the energy and matters cross-cutting concept. So, for example, changes to the atmosphere that result from burning fossil fuels. And they can be focused around that as both in 3 and in 4. Another example would be thinking about the electronic devices that students use, and having to think what happens before in order to get those made, what are the materials, and then what happens after they're done using them. So principle 5, these are complex decisions when it comes to people and how we use our resources and how those impact natural systems. So there's a lot of factors.
And Barbara, I used to think of this principle as applying more to the higher level grades, but even in kindergarten, students are making decisions that have effects on the environment. Whether they decide to put their aluminum can in the recycling bin or the garbage, we all make decisions that affect the environment.
Yeah, so then we try to think of the different levels of decision makers. Who are the decision makers? They can be kindergarten students, high school students, younger, older.
Individuals, government, so sometimes we have to come up with laws and decide what people are going to need to do.
Mm-hmm. And what kind of private decisions can be made, and then what kind of public decisions are made. But we can all do some individual decision making to make a difference.
Okay, so now that everyone's up to speed on the EP&Cs.
Here's just a quick shorthand version of them, just to remind us. And now let's go back to the original phenomena we had. We want to give you a chance to chime in. What kinds of connections do you see now, looking at this event that occurred over time and looking at the river that's a part of this? Just in the comment box, I think it's called the question chat box for you. Write in any responses that you have and connections that you see. While you're doing that, Christy and I will go on and talk about some of the things that we've anticipated some people might see, and then as we see your comments come up, we will speak about them too.
Well, I could even just think about starting with principle 1, We depend on natural systems. We depend on that river for water. The miners were depending on it for gold.
And I like to kind of think, while we're waiting for responses, I like to think about what this kind of provides a so what of learning. Why are we learning this? The students can connect to that.
Yeah.
Feel that motivation.
So why should I care?
Yeah.
Yeah, and we do have a couple of comments, Barbara. Paul is commenting on erosion, water use, exploiting minerals, human actions, environmental change. This could affect the flow of water downstream. Some destruction of habitats. That's principle 2, influencing natural system. Greed.
Yes.
And then decisions had to be made regarding money versus environment. That sounds like principle 5.
Mm-hmm.
So I'm seeing a lot of, I think you could probably connect this phenomenon with all of the principles.
Yes. And so you would choose which ones made sense that you would focus on with your students. And I think also we see that this is current now. Even though this is a historical event, our current practices still rely on mining, still rely on extracting resources, and still have these impacts that were mentioned by the people.
We're still mining, and I go to that area of the river that we see on the right side there. We're still seeing the impacts from the mining that occurred so many years ago.
And Christy, you said this river is very familiar to you.
It's very close to my house, yes. So let's talk about some of the NGSS connections to this particular phenomenon.
So we look at this, when you look at this particular NGSS standard about rainfall shaping the land, and you look at water, ice, wind, living organisms, well, we are a living organism. And we can look at how this does impact, as one of our guests replied, that it can impact the erosion that occurs in this river. And we can look at this, there's no impermeable boundaries when we see the influence of the mining. So now a gold panning simulation becomes more than just an activity that learns about this history process, but it also connects to a bigger relevant idea, and realizing that often when we go about extracting resources that we find valuable, we kind of ignore the environmental considerations, and that can become part of our decision processes. They can also use the power of water to wash away whole hillsides. It's no longer a one-time learning event, if you learn about that, but it becomes part of a whole year of thinking about how actions through history and our daily lives can impact long-term impacts on the environment.
Okay, let's look at this 3rd grade connection, Barbara.
Okay, even though this is a 4th grade historical event, you can connect beyond the grade level that these particular events go with. For instance, 3rd grade about changes in the environment can impact how species survive. And in 5th grade, as students study the physical science concept that matter is made of particles too small to be seen, they can look at the mercury particles that were produced as a result of processing the gold.
So let's move on to another phenomenon. And this one I think everyone can relate to, from very young to the very old. We all produce waste. And Barbara, I think you know that many years ago here at Cal Recycle, I was a landfill inspector. And I saw firsthand that there is no away when it comes to waste.
Yes. So the creation of trash. Humans create a lot of trash in our basically living activities. So what do we do with all this trash? Where does it go? What problems does this cause? What solutions can we act on in order to manage this trash and maybe reduce the disposal amounts that occur and how they impact the environment? So as you look at this, you can be thinking to yourselves, what EP&C connections do you see? How do you see this connecting to perhaps some history, social science standards that are there? Looking at the EP&Cs, we noticed that some of these principles on the left-hand side are part of this whole trash idea, producing trash and what happens to it. We can look at cycles that humans depend upon and that we alter. and the fact that decisions are complex. So if you look at the cross-cutting concepts, all of this can connect to the flow of matter in landfills, the natural and human waste systems. We can look at lots of cause-effect ideas, such as the byproducts of our human activity. And we can also look into decomposition rates by what takes longer, what takes just a small amount of time. And then this whole idea, when you look at decisions that are complex, it's not just my trash we're looking about. We're looking at a whole community's worth of trash. We're looking at a state's worth of trash, a nation's worth of trash, a world's worth of trash. So the idea is, yes, we want to come up with solutions, but we all kind of don't want it in our own backyard.
Okay, so Barbara, I know one of the science and engineering practices with NGSS is analyzing and interpreting data, and CalRecycle has a lot of data related to waste disposal and recycling, and I thought you might find this interesting. So let's look at a comparison between the amount of waste that was disposed in landfills from 1989 to 2017. So what do you notice?
Well, I'm kind of celebrating because I noticed that it was reduced in those years. So then I start wondering, why? What happened? What caused this to be less disposal in 2017 from 1989? And this is an example of, you can use data as the phenomenon that students study and want to find out about. So you can present them with a chart such as this that presents some pretty amazing data that they will want to pursue, and that can be the question that they end up studying.
So let's look at some more specific NGSS connections, then we'll look at some more data and we'll talk about the explanation behind some of that.
So looking on some NGSS disciplinary core ideas that can be touched upon with this. Fifth grade has a whole standard about matter cycling between the air and soil and among plants. So you can tap into that by using models that students will develop as they try to show how that matter cycles and how it goes from one place to another. And they can use the waste as part of that. Then we can go on to another one in fifth grade, that matter is made of particles that are too small to be seen. So that connects in that we cannot always see what happens, but we know that it is happening.
And it makes me think of methane gas that is formed in a landfill.
Yes, so that can be part of that model. And then when we look at conservation of matter, like you said, there is no way. It's somewhere, even if it looks like it's going to vanish. I like the fact that we can go all the way back to kindergarten and notice that where they are asked to realize that things that we do to live comfortably can affect the world around us. But we can all make choices that make this impact a little bit less. And they also are studying that plants and animals can change their environment, and that includes people. So we can look at how people are changing the environment, either for the detriment, or also often people are busy doing things to help improve the environment too.
And how about second grade?
They have a whole standard about the structure and properties of matter, kind of a simpler standard than the fifth grade. And so we have some second grade teachers that are using the landfill as a basis, and the fact that they do recycling. So they're actually using that as their way to connect to different types of matter and how they can describe the qualities and the characteristics.
And metal and all those different.
And so then they connect it to a recycling game. And so that's put into the standard and make it a lot of kind of fun for the students. And not to leave out social studies, where is the garbage? That's a lot of our civilizations. When we start new civilizations, where does the garbage go? Archaeology is a lot of times a study of the garbage, the remnants, the evidence of how people lived long ago. When we're looking at primary sources, we can infer in the journal entries as to what happened to the stuff. And of course, migrations, there often were environmental causes and also environmental impacts that occurred when there are people migrating from one place to another. So, Christy, let's look at some examples. We're going to now go into some details with some possible data analysis that can be done in a lesson for students to start figuring out this whole thing about waste. here, Christy, what do you see?
Well, I see a couple of big dips, one really big dip there. I also see the bottom axis, 1990 to 2013, so a long period of time. That y-axis, it's hard to read, it says thousands of tons. I'm noticing that it doesn't start at 0.
Yeah, and so I wanted to bring up the fact that after we developed these charts, I went to a 5th grade teacher and also ran a few by a 4th grade teacher and asked them what they thought the feasibility was of using these graphs in their classroom. And this 5th grade teacher was really excited. She saw that the idea that it starts at the 27,000 number was something that she could use to help reinforce math practices and to help connect math and science together. So she would just start it like we did. What do you notice about this? And then she would do some scaffolding to help.
And for our teacher audience, I do want to comment about the cause of some of these. I saw someone in our chat box commented about EB 939, required cities to reduce their waste. And that's right, Patricia. That was a law from, I believe, 1989. So you see a big dip there. I believe that second dip has something to do with the recession. When people don't have as much money, they don't buy as much stuff, and then they don't throw as much away.
Mm-hmm. But it also, when we're looking at some data, it looked like it started happening a little before the recession, so we had some questions about that. Of course, with students, we wouldn't want to answer those right away. We'd want them just to notice and wonder and develop these questions, look at some more graphs and data, maybe do a couple of readings, and then they could come with conclusions.
Speaking of more graphs.
Yeah, so Christy, what do you see in this one?
Well, I see lots of colors, and I see bar graphs and line graphs, and I noticed that on the far left, it's total disposal, and that is for the waste being landfilled, and then that lined graph is for the pounds per resident per day, which it's nice to see that's mostly gone down.
So when I presented this to the 5th grade teacher, I was concerned because I thought she might say, oh, Barbara, that's way too much to do with my students. But she was actually excited and said, you know, I could still place it in front of students, have them do a noticing and wondering, look at their questions, and use that to help drive the learning and how we would discover what this graph is. We like to think about graphs telling a story. So have the students look at each piece of it separately as they have questions about it, then put it together to tell a story. This tells a similar story to the previous one, but students will notice it doesn't look like it's such a dramatic reduction. So places we can look at are some of the features, such as this one starts at the year 2006. It also starts at 0 there too.
Yeah.
So excellent opportunity for looking at scale, for looking at the mathematical thinking that goes with doing data displays and how we can change the message by how we display our data.
And in the resources document that is in the handout box, there is a link to some of this CalRecycle data. So Barbara, what is in that waste that we're disposing? What are we disposing of? What do you notice?
Well, I noticed that this big section in green is the other organics. And then there's a couple other fairly large ones too, the inerts. Can you tell us what those are? The other organics?
Well, the other organics, food waste and yard waste, the stuff we put in our green waste bin. That's going to be the bulk of that. Inerts, concrete, rock, non-organic type of material. So that's the bulk of it.
Mm-hmm. And students will notice the others too. And then we go on to this one, that's the top 10 landfill materials. And I notice, and I know students would notice, that food is a huge percentage of what's put into the waste stream. So that's the big message of this. Is this something we can have control over? We might not be able to have control over everything that's on that list, but what can we do
Well, and I think the way this data is presented is more accessible perhaps to some of the lower grade students.
Yes,
as well.
in fact, I ran this by some younger grade students, and they knew that, they just said even though they're not familiar with percentages at that age, they can look at the relative amounts and the lengths of those bars and do a lot of questions and figuring out with their students.
Okay, so again, we just want to reinforce organics is this huge part of the waste stream, and organics can, in the landfill, decompose and turn into carbon dioxide and methane gas. Both are greenhouse gases. California, CalRecycle is really working on trying to reduce that amount of organic waste that's going to landfill.
Yeah, so what are some things that can be done? But first of all, I think we have another way that we can present phenomena as we look at our next slide.
That's a lot, Barbara.
Yeah, I find that sometimes I will present headlines to get students into looking at a phenomena like there's tons of food.
You say, no way, that's a lot.
And we try to get students familiar with what does that mean by billion tons, because that's a huge number, very hard for students. Million tons is even, 6 million tons, hard for students to picture. So we can do a lot of little exercises that get students to look at how much it would be for a bathtub full, how much it would be for our whole house full, so they can get towards that.
But I have something they can do with it, Barbara, which is leading us to our next phenomenon. You know, I love this, worm composting. I am a worm wrangler. I've got lots of worm bins at my house, and worms are a great way of managing food waste. Our preferred method is to not let it get too rotten, and that people are using the food while it's still good and sharing it either with other students or with a food bank. So I think you're going to see that there are a lot of connections to many different grade bands with vermicomposting, and it's a way to solve a problem. And I think there's a lot of NGSS that's about solving problems.
Yeah.
So I wanted to point out, and that's a photo from one of my worm bins. I'm so proud of them. They're hard workers. There are worm bins are being used in one of the learning sequences at this upcoming NGSS rollout that's focusing on environmental literacy. So I highly encourage you to attend the rollouts. That information and how to register is later on, but they're using it at the rollout and the 3 through 5 session on the cycling of matter and for modeling. So many of you are familiar with the EEI curriculum. This article on wonderful compost from a student reader is being used at the rollout as well. And some of these EEI resources can help the students with that sense making. They may be wondering and making observations and then later bringing in some of this kind of material where they're going, oh, okay, and it would help them with revising their models.
So we've often found we just reverse the order of the materials in the EEI curriculum, and that they do the text later on, but they do these investigations first of all.
So what are some of the connections, Barbara?
So we found that we could look at this in several grade levels, so we're featuring just a few. We have performance expectations in kindergarten where they communicate solutions. So worms can be used as a solution. In 3rd grade, they use evidence to support the fact that traits can be influenced by the environment. So as we look at these worms in the soil that they produce in the compost, students could do an investigation where they grow plants in the compost and grow plants in maybe some soil that isn't as nourishing, and compare how the traits are different in that they grow taller and have larger leaves when they're in the compost. And then in 4th grade, there's a study about internal and external structures. So you could actually feature the worm and what are its structures that help it to process that soil. So here we have looking at the human impacts on earth systems in kindergarten, and this standard that we've seen before about that people live comfortably by affecting the world around them. We can also go on to looking at 1st grade and the fact that again, looking at the structure and function of external parts, and that the animals use these in different ways in order to survive. In second grade, there's a focus on biodiversity, so worms increase the quality of the soil so that it supports a variety of plant and animal organisms. And this third grade one that we looked at the PE for, the environment affects the traits, but there's also this whole idea of ecosystem dynamics, where it affects ways in that, that we can have changes occur, and that could be that we get some more worms, or they're destroyed where they live. Is, you know, just even by walking over the soil, we compact it too much for worms to do their job, and so it might cause some plants or animals to have to leave the space or just die. And we can look at in fourth grade, again, we talked about in the PEs the structures for growth, survival, behavior, and reproduction. And fifth grade, the cycling of matter and how natural systems cycle it. And this can be like a little mini system that they look at that represents what happens in the natural world.
Right, right.
So let's look at some other environmental phenomena that can be used to drive NGSS and social studies phenomena too.
There we go.
So everyday lives, we use paper. We use paper, lots of paper. And I've worked with teachers who have students stack all the paper they use for a couple of weeks and look at that paper and what's in it and what could be reused, what they could do with that paper, and just notice the amount of paper they use. Chrissy, you also have a teacher colleague that you know does something with paper.
He had all of his students collect their junk mail and then bring it in, and they did this terrific video documenting like a waste audit.
Yeah, so then with kinders, we're getting those students aware of where that paper comes from, what are the resources, and then they decide they like having trees around, so then they come up with some action projects that they can do both themselves and also as a class, and even go further into the school. Oops. So another key resource, and we could feature many, 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 but water, such a key resource. Just we need it to live. This can go through lots of different grade levels. In kindergarten, we're just trying to increase the awareness of where this water comes from and just realizing how precious it is and what we can do to help conserve it.
And these are EEI kindergarten unit resources, but as you can see with the visual aids, they could be used at a variety of different grade levels.
Yeah, and that's part of the purpose of this webinar, is for you to see that there are some resources available that can be used in any grade level depending on where you were going with that. So in GALT, we noticed that we are using that we actually share with students about the human systems and natural systems and how those connections occur, and students then start identifying those ways that they occur throughout the day. In this case, we have a visual where kinder students or others could use those photos to talk about natural systems and get the big idea of what natural systems is about. We can also use these as ways to visually talk about how we can conserve these resources and make some decisions. Again, Principle 5. So looking at the human impacts of these activities, fifth grade takes it beyond that kindergarten standard and looks at a little more complex issue of the agriculture, industry, everyday life, and how those human activities affect our land and resources, the environment. And then this is an engineering performance expectation to come up with some multiple possible solutions. So they can evaluate solutions that have already been done by people. They can also come up with their own solutions and evaluate each other's. So we're connecting it to a few more grade levels. Second grade learns about where water is found. So through that, you can connect it to the environmental considerations that it's very precious where it's found, especially the fresh water. And then in fifth grade, really gets into fresh water versus salt water and where it's located. And there's such a tiny fraction that's available for us to use. Then just in second grade, again, you can look at the plants depend on water. So where does that water come from for those plants to have?
Okay, so let's move on to another phenomenon. So another way to have students encounter phenomena is to actually go to a place where natural systems thrive.
And so just south of Sacramento, there's this marvelous place called the Cosumnes River Preserve. And if you take a look, that's where those egrets live. and there's several other places that are available to the public. So students from Galt and other places no longer call this a field trip, but a field study, when they actually go and they study, and they also participate in restoration activities. So they also can learn about wildlife-friendly farming. There's an island on there where this part of the reserve that practices wildlife-friendly farming in their operation, and it becomes profitable. We've actually had students go out there and feel inspired that they can, in their future goals for what they want to do in their field of their career field, how can they do practices that would be sustainable for our earth?
So I think the students are actually quite active out at this preserve.
Yeah, if you take a look at this picture, they plant acorns that were harvested in the fall by other students. They might plant seedlings that have been grown by other students for a while from the acorns that were harvested. They also water previously planted ones, and students actually get to see the forests that are now there that were planted by other students from 5, 10, 15, 20 years ago. And they can see that rate of growth and realize it takes a long time for a tree to get its height. So, as was obvious, I'm sure to most of you, Principle 5, making these decisions, it took a lot of people getting together to partner to provide this land, this wildlife-friendly land, so that people could go see it, but also just so that these different organisms could thrive, and based on natural cycles. Exunas River Preserve is actually the last undammed river on the western slope of the Sierra Nevada, so it's a unique place. So you can take a look at these performance expectations. We have kinder, first, second, and fourth grade, just that can be all connected to going out to the reserve. There's many, many more. So a natural
Cycling of matter, you could do that fifth grade one here too.
Mm-hmm.
There's so many, we can't even fit them all on the slide, right?
Yeah, we just wanted to give you a few new ones that we hadn't talked about before. And another example, here's an EEI resource. It's a book that's very, that fits exactly in with these third grade performance expectations. And as students do this, the first chapter talks about the traits that plants and animals use to survive. Second chapter talks about changes people made to that salt marsh and the impacts on the plants and animals. And then the third chapter focuses on the changes that the people made to try to restore the marsh to make it more friendly for these organisms to live.
So I see a lot of EP&C connections.
Yes, and then the students, engineering standard, they evaluate the merit of the solutions that the people enacted that they can read about, and then they can come up with their own solutions. Also, the idea is you can use read-alouds, novels, all sorts of informational or fictional text that to connect to environmental awareness. So, Christy, how about you talk about this idea of defining the community?
Well, we want to make sure that everyone feels comfortable that they can go out and start identifying their own local phenomena. So I think one of the first things you want to do is to define your community, because you should be finding the phenomena to a large extent within your own community. So with those early grades, looking right in your own schoolyard. Heck, if you got a worm bin, you can look right in your classroom, right? Or at students' homes. Some of the younger grades in their community, just in the neighborhood. Intermediate grades, looking more regionally, state, the nation. And then middle school, high school, really looking globally.
You can go as close as like what you said at your school, grow some gardens, look at any natural areas, or even areas that are kind of human developed on your school. You look at your neighborhood. Fish hatchery is an example. There's local parks. Of course, we know there's state parks and national parks too.
And speaking of state parks, I want to give a shout out to California Department of Parks and Recreation. Some of you may be familiar with their PORTS program. It stands for Parks Online Resources for Teachers and Students. You can have a ranger, a naturalist at one of the state parks virtually join your classroom in real time. I experienced one of these with a ranger at Point Lobos on a kayak. It was amazing. So the resources page, and again, and your handouts, you can find the link to ports. You can also find a link to CREEC, California Regional Environmental Education Community Network. And you can find people in your area that can help connect you with these types of resources.
But the underlying idea is go outside.
Yes, exactly. And as you're going out on these field trips, we encourage you to make sure you're making the social studies, science, and environment connections. So really using those EP&Cs, like for example, in this one, this is Grinding Rock State Park, southeast of Sacramento, looking at how the Native Americans really depended on those natural resources. And they influenced that rock too, didn't they?
And I found when I took students out to Sac State for a science and a career development field trip, we went and walked across the Guy West Bridge and looked at the top, overlooked the river. And we did a lot of environmentally related questions and looking at that habitat and what people had done to change it, but how it also still could support a lot of life there. So we took the opportunity that we were off campus for a different purpose, but we connected to the environment. And that's the idea here, is have that environmental lens throughout whatever you do, and you'll see the ideas just flowing.
And you don't have to go anywhere. So let's just take another look at the environmental principles in California and where teachers can find these. Well, they're in that handout and they're on the CalRecycle website for EEI. But you're going to find these environmental principles and concepts woven into the California Science Framework. They're within the chapters, and there's also an appendix that is specifically focused on the EP&Cs. You're also going to find the EP&Cs in the new adopted science materials, actually, and history social science as well, I will mention. So I know a lot of districts are going to be choosing materials soon. So look for some of those strongest connections in EP&Cs. I also want to point out there are some explicit type connections in NGSS and the standards, especially with the ESS standards, Earth and Space Science, so the Earth and human activity. But there are also so many opportunities to make these inferred connections, and that's really how we want the teachers to apply these EP&Cs. Like you can think about how with decomposition, wow, humans really depend on that. What would the world look like without decomposers and scavengers? So there's so many places we could weave in EP&Cs where it's not explicit.
Yeah, I like to think of it as a thinking thread that's just woven throughout the day, throughout the week, throughout the year.
And Barbara, I think you have more tips for weaving EP&Cs into lessons.
Yeah, so one big thing is just to think of some generic questions and prompts that you can do to engage EP&C thinking, and then have a visual that's available that students can see so they can generate those. Consider the environmental role in natural and human-built systems, and think about how students can connect those human and natural worlds in the things that they are studying and their interdependence. Look at cause and effect and systems relationships. And I just talked about environmental visuals that you can have on the wall for students to make the connections themselves. And especially look at local connections. And I like this what if game. We have students, even young students, as a very simple way to make a connection to the environmental. Just let's say that they're looking at the grass that's growing in front of their classroom. You know, what if everybody walked on that grass every single day? What would that do to change how well that grass could grow? You know, what if when we're doing another item, you know, what if people did this?
What if no one ever turned off their faucet on the water?
Yeah. What if everybody left the water running when I'm brushing my teeth? So just that what if game gets them to think, okay, and then you can do what ifs for what if everybody only used one paper towel instead of grabbing 2 or 3 when they dry their hands after washing them at a public restroom.
So it could be good things too.
Yeah, you can look at both, and they could see the power that can happen when we just make a little tiny tweak in our behavior.
So Barbara, it's time for our final poll. So we would like to ask our audience, how will you use environmental phenomena to teach science? And I think through this we see that, videos and media can be good resources.
Yeah.
There are a lot of places we can't go.
Right, like we used videos for that gold rush one because we can't go back in time. It's great to have the first-hand encounter with some phenomenon, but that isn't always practical. And show the results.
Share.
So everyone can see. So lots of you said videos and media. We have looking at the school grounds and local providers. Do we have anyone, Christy, that's added some ideas to the left?
It was set up so that we could only choose one. I apologize for that.
We had meant to have it be multiple, so that's
yes,
something that
if we do this one again, we'll change that poll. I apologize. So maybe that's one of the reasons why the first choice has the most answers. But I'm hoping that it says 0% chose the last one, and I hope that that's actually true. I hope everyone is planning on using environmental phenomenon. Yeah. So let me close that, and we just have a few minutes left here, Barbara. Again, I want to encourage everyone to participate in these NGSS statewide rollouts that really, the whole focus is on environmental literacy and how you can weave the EP&Cs into NGSS learning sequences. You will experience as a learner learning sequences. So I got to go to the Trainer of Trainer events. You're in for something awesome. And starting October 8th and 9th in San Diego. And
so information about this is in the handout that has resources listed in it for you.
Okay, and I see we have 1 minute left. This is just a sample of the types of resources you'll see on the resources page that we put together for you in the handouts.
And so just to let you know, we are working on some upcoming resources for teachers. So watch for new arrivals and webinars, but also some other resources such as some learning sequences. So instead of what we're doing right now, where we're just showing some examples, we are actually establishing grade level learning sequences that are in the form of lesson plans that illustrate how to weave the EP&Cs within NGSS sense-making lessons. So what would you like to see as future resources to support your efforts? We have some ideas, but we'd really like to take your ideas as we're looking at what we're doing in the next several months to support your work.
Yeah, and this could be in the form of additional webinars. What topics would you like to see? Learning sequences that we might be able to develop. Just what's on your wish list to help bring environmental literacy to your students?
So just go ahead and write away on that comment box there, and we're going to leave the webinar open for a while so that those that want to contribute ideas there and or suggestions, we'd love to have that. Any feedback also is welcome.
And Barbara, I want to point out we've got, I added our EEI mailbox here, so if folks have specific questions or comments, you can write to us at eei@calrecycle.ca.gov. We want to thank everyone for joining us today. I know we were moving at a pretty fast clip. We just couldn't decide on anything to cut out. We were too attached.
Well, actually, we did cut out a lot, Christy, at first. So stay tuned because there's some other ideas we have that we can put together also for there. But we wanted to give you some variety in this one.
But we're really hoping that we've inspired you to bring environmental phenomena into your classroom with your students and starting to see phenomenon in your schoolyard and beyond.
Yes. So those of you that aren't, there are some of you that are still adding suggestions or questions that are there. We'll stay with the webinar open so that we can maybe address some of those questions. And for those of you who need to go on to other things, thank you for being with us.